So we're starting with this problem today, where we're just solving this square root equation for x. Now, we've only looked at one way to be able to solve that, and that is to make a graph. And so that's what I would do in that case. When asked to solve it, make a graph. So go ahead and graph the left side, graph the right side, and let's see where they cross to solve it. So in order to graph it, we start by just graphing the left side. So square root of x plus 6 plus 3. That plus 6 tells me to go left 6. The up 3 tells me goes up 3. So I'm putting my first point right there at negative 6, 3. And from there, I'm making the same old square root graph that I always make. So over 1 up 1. Over 4 up 2. Remember when I say over 4 up 2, that's counting from our first point. Then we go over 9 and up 3. But we can actually fit one more point on there. And I don't know if we've talked about this one, so let's make sure we know where that is. So the reason why I go over 9 and up 3 is because I can take the square root of 9. The square root of 9 is 3. What's the next number you can take the square root of? 16. And the square root of 16 is 4. And I can actually go over 16 and up 4 to get that point right there. So you get that point, plot it, make note to yourself that we can go over 16 up 4 if you need to, so you remember it for future. And then we can draw our curve in.
I don't understand.
All right, and then having done that, of course, we just needed to graph the rest of it, which is y equals 7. Y equals 7, remember, is a horizontal line up at 7. So when all is said and done, you're looking at this graph. Now, we still need to solve it. So, remember the solution is the x value where they cross.
10.
What is that x value?
10. X equals 10.
There we go. So x equals 10 for our final answer here. Now we did this problem to remember how we can do some of these with skills we've already learned. But here I'm giving you an ever so slightly different problem. Notice this one is asking you to solve for x again. It's the same equation on the left side, but it equals 12. That means that if I was going to try to solve this, that line for y equals 12 would be, well, it'd be like way up here somewhere, right?
Yeah.
And I would have to go way over to the right to figure out where they cross. I don't really want to have to make my graph that big. So, because some of these numbers can get insanely large and difficult to graph, we're going to see a new method today. We're going to see how to take this same equation and solve it algebraically. So on line paper now, please write down this equation. And for this problem, we're going to walk through the solution together, just going step by step, seeing how we go about solving it, and then you'll have a chance to practice some more on your own using what we see here. All right, so first thing I want to do, step 1 is to get the square root by itself. So if I want the square root by itself, notice what's in the way of that at the moment. The 3 is in the way, so I need to get rid of that. So how do I undo that plus 3?
Minus 3.
Minus 3, yep. And just like we've been practicing with our algebra, I want to see that clearly shown under both sides, minus 3 and minus 3. When I do that then, the next line shows what's left. So I still have the x plus 6 inside the square root on the left side. And on the right side, I do the 12 minus 3, which gives me 9. All right, now I have that square root by itself. In order to get rid of the square root, we are now going to square both sides. All right, now to square both sides, there's not a nice, pretty way to show that we like square both sides. I'm not really going to write like to the power of 2 to the power of 2 under both. And so I'm actually just going to put parentheses around this and show that I'm squaring it. It's just a way of showing I am squaring everything on both sides. All right, so the next line. The reason why I'm squaring it is because squaring a square root undoes it. Which means that if I square that square root of x plus 6, I am left with x plus 6. It made the square root disappear. And then on the right side, I'm also going to do the 9 squared. 9 squared gives me 81. So notice the reason why we got the square root by itself first is because that's the only way we can get rid of it by squaring both sides. If you tried to square both sides at the start, you'd actually end up with one heck of a mess if we did it correctly. And so you get it by itself, then square it, and now it's an easy equation to solve, right? What do I do next?
Divide.
Minus 6. Because it's currently x plus 6, and I want it to just be an x, so I subtract 6 from both sides. 81 minus 6 is 75. And so there is our final answer. X equals 75. Which, when we look at it graphically, we know that's where like the left side would cross the right side. On this one, what does that really mean? Well, again, it would mean that if we graph these, we'd have to go out to x equals 75, but we'd see the two graphs cross. Another way we could see what it means is that it means that if I took that 75 and plugged it in for x, I would end up getting 12 on the left side and on the right side. I get the same thing on the left and the right. So notice it'd be like square root of 81 plus 3 equals 12, which is 9 plus 3 equals 12, and so 12 will equal 12. Now, this is not the work that you're actually doing, but I'm just doing that to show you and remind you, what does a solution really mean? The solution is, what does it actually take to make the left side equal the right side? Now, I don't give a whole lot of notes in this class, but I do give a little bit, and when I do, it probably means it's very useful for you to have written down. So please now add this into your math notes, and when I say add it into your notes, that means put it someplace where you can find it easily later and look back at it. So as you get these into your notes, you notice this top section, the solving square root equations. These are your steps. Step 1, isolate the square root. Use your normal algebra skills to do that. Once you've isolated the square root, then you square both sides of the equation. And squaring both sides makes that square root symbol go away. Because remember, squaring undoes a square root. And then from there, it's just the normal algebra steps that you would do. So no special instructions, you already know what to do once you've done that. And then this part below here. So we just solved the square root equation algebraically because it was equal to a number. We still have to be able to solve it using a graph if it's equal to anything else. So like if we have our square root equal to an absolute value, you still need to graph both of them and look to see where they cross. So here's a new equation. Please go ahead and solve this one out on your own, showing all steps, doing the work neatly, because this will be something you can look back at later as well. And then we'll go through it once you've had a chance to complete it on your own. All right, so first step, remember, is to isolate the square root. So in order to do that, that means getting rid of the 33. So I'm going to add 33 to both sides.
Yeah.
When we do that, the square root on the left side is as it always was. It's x minus 18. Equals, now negative 30 plus 33, you should get 3 there. Now that I have the square root isolated, now I go on to step 2 of the process, which is to square both sides. And so I'm just going to square each of those. On the left side, remember, squaring gets rid of the square root, and it leaves everything that was inside intact. So that x minus 18 stays an x minus 18. On the right side, I do 3 squared. 3 squared, remember, that's 3 times 3, so that is 9. And finally, now it's just normal algebra as you would normally do. So I want to get rid of the 18. I add it to both sides. So plus 18, x equals 27 for our final answer.